This is the review lesson on uh, proving triangles congruent. Now let's look at the first one together here. So in the diagram, ABCD is a rhombus. Here, the definition of rhombus is that all four sides are equal to each other. Now these three are straight lines, and E is the midpoint of DF. So E is the midpoint of DF. That means we know that this line segment is equal to this line segment. Now, the question is AD? We are looking at this part of the line segment equal to BF, which is this part of the line segment. But if you remember, another thing that which we have to realize was that rhombus, that means all sides are equal to each other, so this side has to be equal to this side. Now, when you look into that, then we get to realize there are two triangles, you see. And so from these two triangles, hopefully we'll be able to figure something out. Now, then here we realize that this triangle is trying to be congruent to this triangle. How can we do that? In fact, one thing which we can realize is that this angle and this angle. Now, when you look into those two angles, what kind of relationship would you realize? Because in a rhombus, this side is parallel to the other side. Therefore, these two angles become alternate interior angles, which makes these two angles to be equal to each other. Then, another thing that which we have to realize here is that this angle CED, must be congruent to BEF by vertical angles. Now, then you can see that the first triangle must be congruent to second triangle by angle, side angle. So therefore, we realize that line segment BF must be congruent to CD, but CD is congruent to AD by definition of rhombus. We get to realize that BF must be congruent to AD by transitive property. So therefore, the answer is yes, it is congruent. Now, second question here. We realize angle D is congruent to angle B. All right, so that's the first condition. And then these two lines are parallel. As soon as we realize those are parallel, then this angle C must be equal, congruent to angle A right over there. Now, then the question is DF, which is this line segment, let me just mark it with green, is DF congruent to EB? Now, in order for us to see these two are congruent or not, we need to show that these two triangles must be congruent or not. So far, we realize that two angles are congruent. The third thing which we have to know is something about side. Now, do you know anything about AF or CE? In fact, here, no. So therefore, we don't know anything about the line segment. Therefore, we don't know if these two triangles are similar or congruent. Therefore, we cannot tell if these two given line segments, DF and EB, are congruent or not. Choice number 3. Right. Next, question number 3 here. So we realize that this line segment TR is perpendicular to LR as it is given right over here. And so as RL is perpendicular to LP. Now, so that's one thing that we get to realize. And M is the midpoint of TP. That means this line segment must be equal to this line segment, which statement could be used to prove these two triangles congruent, as we realized that this angle is congruent to this angle already because they are all right angles. How about these two? So therefore, we get to realize that angle side might be quite possibility because these two are vertical angles. They're congruent already. So we get to realize choice 2 would have been our answer. Alright, let's move on. Question number 4. Here in the diagram, quadrilateral ABCD, AC is diagonal that bisects the angle BAD. Then a BAD has been bisected, so therefore this angle must be equal to this angle. And BCD. BCD means this angle must be congruent to that angle. Alright, so we realized two pairs of the angles already that are congruent. Which statement can be used to prove that those upper triangle and lower triangles are congruent? We get to realize that we see that the line AC right over here is common for both triangles. Therefore, it is reflexive, which makes angle, side angle, angle, side angle will be our method to solve proving these two triangles congruent. Choice number 3. Here comes question number 5. First, we realize that this is a quadrilateral with diagonals given as it is shown, which bisect each other at x. That means this line segment will be bisected, so as the other two line segments will be also bisected. Now, then we want to show that triangle B and X. B and X, this triangle, let's call it triangle number 1, and here, triangle number 2. That's the congruent. As soon as you look into that, what else do you realize? Yes, in fact, we get to realize that this angle and this angle, angle BXN, and then OXR must be congruent by side angle side. So that's the idea which we like to look at. So, first statement was that this is a quadrilateral. That's great. Now, our second statement which we have to realize was NR and BO are diagonals. So here, what we have to write is NR and BO are diagonals. Alright, now they bisect each other, so therefore, in this case, we can say definition of line bisector or we can actually write them down saying that a bisector divides a line segment into two equal parts. So we could actually write that down if you want to. And as soon as you realize two intersecting lines form congruent vertical angle, in this case, this must be the reasoning for, as I mentioned, these two blue dots, as in angle BXN must be congruent to angle OXR. And then, as we mentioned, it was side angle side. Alright, let us move on to number 6. So here, D is the midpoint of the line CD. So once again, we get to realize that and this line segment must be equal to this line segment. Angle ADC, which means this angle, must be congruent to ADB. This one. They have to be congruent to each other. Now, then how can we prove that angle C, let me use the green one, angle C is congruent to angle B. Now, one way which we can do is we need to prove that the triangle on the left must be congruent to triangle on the right. How can we do that? In fact, we get to realize that between these two triangles, we have one side that is common, AD. That must be reflexive. You can see the reflexive property. Here we realize that AD must be congruent to AD. Now, how can you say CD is congruent to DB? The reasoning must be a midpoint divides a line segment into two congruent parts. Now, then how can you prove that these two triangles are congruent? By side angle side, as you can see. And then why are these two angles, green dotted angle C, angle B, are congruent? By CP, CTC. So corresponding parts in congruent triangles are congruent. All right.